People, good morning class. Today we have a special edition. Exponential equations. Yes. What?
Yes.
Right, exponential equations. Now all the rules of exponents is still evident here. Okay, as we had before. It's still evident. What was your homework in last lesson? So we finished that chapter on. Right. So this is we're going to do some exponential equations, and then next week we're only going to do revision before you write your exam. Okay, because I want you guys to do well. No? Do well. Sorry? No, this is worksheet 12. See, this is from another textbook. It's from the X Factor. A very good textbook to have. Okay, you guys can buy you this textbook and you can use it as extra material to go through, resource to go through. It's a very, very nice book to have. So it prepares you well for the exam. Solve for X by inspection. Alright, let's look here. Wat gaan hier aan? So we're going to write here. This is from the grade, I think it's a grade 8 textbook. Grade 8, X Factor. Factor, no? This is worksheet 12C. Okay. So the question says, so what I'm going to do is we're going to do all the odd numbers together, and then the even numbers, of course, is going to be homework. Yes. So you guys had a good day off yesterday since you didn't have no maths homework. You were struggling. Studying for what? Doesn't sound so easy. Yes. Right, here we go. Listen. Come. 1.1. You got 2 to the x equal to 4. So what must x be equal to? 2. Who said something else? Who says something other than 2? Who can tell her why you're saying 2? Yes. 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 So what do you want to say it's going to be? Okay, so in other words, what she's saying is, she's saying 2 squared is 4. So if you got 2 to the x is equal to 4, then 2 to the x is equal to 2 squared. When bases are the same, exponents are equal. So x equal to 2. But it says by inspection, so you don't have to write it down. You can just go straight. Go with 1.3. Sorry? So you got 2 to the x equal to 64. 32.
No, 8.
How do you get 8?
It's 4. It's
4. Why do you get 4? So you say x is 4. If x is 4, then it's going to be 2 to the 4, which is 2 times 2 times 2 times 2, which is 16.
16. That's right, 64.
Okay, so what you ask yourselves is the following. Okay? Let's go with 64. What number, the prime number that goes into 64? 2. 2 goes? 32 times. 2 goes? 16. 2 goes? 8. 2 goes? 4. 2 goes? 2. 2 goes? 1. So in other words, 1, 2, 3, 4, 5, 6. So 2 to the x is equal to 2 to the 6. When bases are the same, exponents are equal. So therefore x equal to? You guys understand? Now you try for me 1.5 quickly. Okay. What's it? Why are you putting that stuff in? There's nobody sitting here and there's nothing big. Through the window.
Yes, sir.
Maybe they're checking with their friends. Okay. 1.5. What's the answer? 3 to the x is equal to 81.
Yes.
So 3 to the 4 is equal to 3 to the x. So therefore x is equal to? You guys done with 1.7?
No.
No, yes Michael. What don't you understand? Okay. So you look at 81. Okay. The idea is to write the bases the same for the exponents to be. Make it out there. When the bases are the same, exponents are equal. And then you add this here. You've got a to the x equals a to the y. Therefore, x is equal to? When bases are the same, exponents are equal. Alright? So, if you look at 81, so we're going to try and write 81 as a base of 3. Can you see that? So this is a prime number, so I can break this up into products of its prime numbers, prime factors. So can 2 go into 81? No. But 3 can. 3 goes how many times? 27 times. Then 3 goes? 9 times. 3 goes? 3 times. 3 goes? Can you see that? So in other words, 3 to the x equals 3 to the 1, 2, 3, 4. Can you see that? So therefore, x is equal to? Yes. Like number 10. Then you try and write 1,000 as a base of 10. If you got 10 to the 1, it's going to be 10. 10 to the 2, it's 100. 10 to the 3, 1,000. 10 to the 4, 10,000. 10 to the 5, 100,000. 10 to the 6, 10 million. 10 to the 7, 10 million. 100 million. A trillion. A billion, sorry. And then so on. You guys will be billionaires, most, no?
Yes.
Not in Zimbabwe.
Yes.
Yes? Okay, so let's look at 1.7. So you got 5x equals 125. So So we're going to try and make the bases again the same. Is 5 a prime number? Yes. So I can use the ladder method. Not so? So 5 goes into 125? 25 times. 5 goes into 25? 5 times. 5 goes into 5? So in other words, 5 to the x is equal to 5 to the exponent? 3. Therefore, x is equal to? You guys understand? Okay. So the next one. Okay, so let's look at the next one. 1.9. So 10 to the x is equal to 1000. So is 10 a prime number? No. So we're going to try and write 1000 as a base of 10. You guys understand? So I'm not going to use a product line over the ladder method. So you're going to get 10 to the x equal to 10 to some exponent. So we say 10 to the 1 is 10, 10 to the 2 is 100, 10 to the 3 is 1000. So there we go. So therefore, x is equal to? You guys understand? So for homework, I would like you guys to do the even numbers. Can somebody take this photo of this? You sorted? You got it? Alright. So now, in the next part of the work, we are asked, solve for x by inspection and check your answers. But you guys are not going to work by inspection, so you had a problem with the inspection, so we're doing it by calculation. We could have checked our answers here as well. Not so? So the first answer was 2, so 2 squared is 4. The answer here was 8, no? So 6, sorry. So 2 to the 6 is 64. 3 to the 4 is 3 times 3 times 3 times 3, which is 81 and so on. That's how we check. Okay. Number 2, solve for x. So let's look at 2. I'm just going to do the odd numbers. No? So you got 2 to the x plus 1 is equal to? So make a note there. In this case, we're going to first isolate the x, or the term of the x. Which means to say, I'm going to get the term of the x on one side and the equal sign. Right? So how are we going to get, how are we going to isolate, or how are we going to get the term of the x on its own? Take the 1 over. So take the 1 over. So what do we get? We got 2 to the x equals 9 minus 1, which is? Now solve for x there now. So I can say 2 to the x is equal to 2 to the 3. So therefore, x is equal to 3. And we can test it. On the left hand side of the equal sign, we're going to say 2 cubed plus 1. What is 2 cubed? 8, and 8 plus 1 is 9, which is equal to the right hand side. Can you see that, people? Okay, or you can do it in your head and you can check. Okay? You all okay with that? Any confusion? Alright, do 2.3 for me quickly. Okay. So what do we do first? Isolate the term of the x in. So we take this 3 over. It now becomes 5x equal to 28 minus 3, which is 25. Not so? So 25 can be written as what? 5 squared. Not so? So what can I conclude now with? Easy. To number 25. 2.5. What's wrong? 3x plus 3 to the exponent x plus 1 is equal to 81. Yes? I said 3 to the exponent x plus 1 is equal to 81. Alright. So, 2.5. Remember, when the bases are the same, exponents are equal. So we are always going to try and write the bases the same. You can already see the term with the x in is isolated already. Not so. So what's going to happen here? 81 can be written as what? 3, yes, it must be written as 3 to the exponent. You all agree with that? So 3 times 3 is 9, times 3 is 27. 27 times 3 is 81. You understand? Now what can we conclude? Therefore, x plus 1 is equal to 4. Remember, when the bases are the same, the exponents are equal. Can you see? Both bases are 3. So the exponents on that base, we equate them. You guys understand? And now? X is equal to 3 or 4 minus 1, which is 3. And we can test it. So it's going to be 3 to the 3 plus 1. What's 3 plus 1? 4. And 3 to the 4 is 81. You guys understand? Do 2.7. Okay? What can happen here? The same. Okay, which is what? 7, yes? 7 to the 2x equals 7 squared. Why? Because the 7 squared is 400. Now what? Therefore, 2x is equal to 2. So x is equal to? Listen, if 2x is equal to 2, you can't take 2 over. This is bonded by multiplication. We divide. Yes. Do you guys understand? Right. Odd numbers for homework. I mean the even numbers. Who's the photographer? Maybe? Right? Make there? Even numbers, homework. You got it? Maybe? Right. Here's 2.9. Is it still 12C? Finish? Yes, sir. Right, so what do we do here? Same thing, yes. Which is what? 2 to the x 2 to the 2x minus 1 is equal to 2 to the 3. The bases of the same exponents are equal. So therefore, 2x minus 1 is equal to 3. So 2x is equal to, which is divided by 2. You got it?
Yes, sir.
So that is from the grade 8 textbook. We will look at the even numbers on Monday. Now this is out of the grade 9 textbook, okay? The grade 9. I'll just take it from here. Right. Right, do the odd numbers, people, don't waste your time. Even numbers, of course, are more. Guys, done with the first one? Yes? Wait. Okay. I wait. Right? Number 1, you got 2 to the x equal to 32. So 2 to the x equal to 2 to the 1. Therefore, x equal to? Nice. Let's look at number 3. So, what's the difference with number 3 compared to what we have dealt with thus far?
It's a fraction.
Fraction. Is that okay? 27 can be written as what? This is the number 27. 3. You all agree with that?
Yeah.
So do that first. So 3 to the exponent x plus 1 is equal to 1 over 3 cubed. Not so? But are the spaces the same? So the first one space is 3 and the other one is 1 over 3. So my plan is to get the bases to be the same. So how can we make the bases the same? How can we make that base the same? Remember? That's going to be 3 to the x plus 1 is equal to 1 over 3 cubed. Remember, we want the bases the same for the exponents to be equal, not so? So I'm going to get that basis the same. Remember, what is x to the minus 1? Remember when we did exponents, we said x to the minus 1 is what? One over x. Don't you remember? Yes, didn't we do exponents?
Yes.
So make a note there. That x to the negative 1 is equal to 1 over x. Which means to say, if x to the minus 1 is 1 over x, then 1 over x is equal to x to the minus 1. Notice it goes both ways. So what happens is, this can come up. So that gives us, therefore, 3 to the x plus 1 is equal to 3 to the negative 3. Now what? Nice, nice. This one. Okay. So in place the same exponents are equal. So you go x plus 1 equals negative 3. You get over the equal sign, so x is equal to negative. Okay, you all got that? Let's look at number 5. Yes? The decimal. Okay. Where is the decimal? No, that's not a decimal. It's times. With dots. Yeah. So if you got 4 times 2 to the x equals 32, what must we do first? No, we can't times it because there is no variable exponent. So I divide by 4 first. Now it's an x. No? 32 divided by 4? 8. So 2 to the x equal to 2 cubed. Therefore x equal to 3. X. Okay. Okay. You guys got it? You say, oh, you're going to get confused. X. People. Number 5. And here they are. 9. X plus 5. But the 27 is to the x plus 5. Iets verkeerd met julle oor. Now make it bigger now, but that's just move it around. Okay, so I'm going to go straight into it. So where the bell is going to ring soon. Which one? Number 5, no? Yes, sir. Look at number 5, couples. Alright. So for homework you're gonna do the even numbers, no? Don't forget. Number 5. So you got 9 to the 2x plus 3 equals 27. To the x plus 5. So the idea is to get the bases the same for the exponents to be equal. Now 9 can be written as what?
9
3 squared. Not so. Raised to the 2x plus 3. 27 can be written as what? 3 to the 3. Raised to the exponent? X plus 1. Can you see that people? Now what's the rule if you have a base raised to a high exponent? You have a base raised to a high exponent, we multiply the exponents. Not so? So what do we have? 3. 2 times 2x? 4x. 3 times 2 is? 6. 3 times x? 3x. 3 times 5? You see that people? So what can I say now? If bases are the same, exponents are equal. So therefore, what can I say? 4x, yes? Plus 6 is equal to? X plus? Plus 15. So what do I do now? X is one side, number side. So what do we get? 4x minus x? 4x minus 3x? It's x. 15 minus 6? 9. Good couple of marks involved there. So probably like 3 or 4 marks. X equal to 9. Huh? Let's look at number 7. In number 7 we got 2 to the 2x minus 3 is equal to 1. Two to the 2x minus 3 is equal to 1. When bases are the same, exponents are equal. So we got 2 to the 2x minus 3 is equal to 2. Hypo. We want the bases the same for the exponents to be equal. 2 to what exponent is 1? 2 to the 1 is 2. 2 to the 2 is 4. Remember, when we did exponents, we said that anything to the power 0 is? Make a note here on the side. Anything to the power 0 is 1. Okay. So in other words, this here I can say 2 to the 0 is 1. So if this was an 8, then I would have made 8 to the 0. If this was a 50, then I would have made 50 to the 0. Does that make sense? So what can we say? Therefore what? 2x minus 3 is equal to 0. Isolate the x, so 2x is equal to 3. Divided by 2, x equal to 3 over 2. Okay. Nothing scary about that. This is from a different worksheet, this one, that we'll talk about on Monday. For now, I'm going to do number 9 and number 11. I'm going to go straight into it, so I would like you guys to pick up now. Number 9. Number 9, we got 9 to the exponent of x equals 3. So when bases are the same, exponents are equal. So we're going to make the base, both bases 3. So 9 can be written as what? 3 3 squared. The raised to the exponent of half x equals 3. When a base is raised to a high exponent, we multiply the exponent. So it's going to be 3. A half times 2 is 1. So it's 1x is equal to 3. Not so? So what, if there's no exponent here, then what exponent belongs there? 1. So therefore, x is equal to? 1. Let's look at number 11 as the last one. You got 5 to the negative 2x equals 1 over 5 divided by 3 over 15. Okay. So this needs to be sorted out first. So I tumble and times. There's going to be 5 to the minus 2x is equal to 1 over 5 times 15 over 3. 5 goes into 5 once, 5 into 15, 3 times. So I'll have 3 over 3, which is 1. So 5 to the negative 2x is equal to 1.
So it's 5 to the 0.
Here we go, well done. So 5 to the minus 2x equals 5 to the 0. So we can now say, therefore, negative 2x is equal to 0. X is equal to? We'll divide both sides by negative 2. Then the answer will be 0. Okay. People, don't forget the even numbers is homework. Yes. Yeah. People, enjoy the rest of your day and the weekend. Good morning, class.